After a lot of back and forth, we're now finally ready to write approve request. Now, one thing I want to remind you about this function is that its goal is to approve a specific funding request. Our contract stores an array of request structs inside of the request variable. So we need to make sure that whenever someone calls the approve request function, they specifically tell us which request they are attempting to approve. To do so, I think we can use a little bit of approach like this right here. So let's say that on the right-hand side, we have our array of requests as a variable called requests. And inside that, maybe we have request A, B, and C. Then maybe Bill over here wants to try to approve request B. So Bill wants to target this one right here. In order for Bill to tell us which request he's trying to target, we're going to say that whenever you call approve request, you have to pass in the index of the request you are trying to approve. So in this case, Bill passed in an index of 1. Request A is at index of 0. Request C is at index of 2. And request B is at index of 1. So because Bill was trying to target request B, he's passing in the number 1 to approve request. Now, one thing you might be curious about here is the fact that we are using an array for handling our requests at all. You might be thinking, Stephen, aren't we going to run into the same issue that we ran into with arrays around our addresses? Isn't this thing going to grow and we're going to eventually have to pay a lot of money in gas? Well, remember, the whole concern around that array of addresses was that we had to do some search through that array. We were searching for a value in the array. But in this case, we are not searching for a value in the array of requests. We are doing a lookup. A lookup operation on an array is a constant time operation, just like it is a search on a hash table. So because we are not iterating through the array of requests right here, we're not writing a for loop or anything like that, this function right here will always be constant time lookup with the requests array. So because of that, because we are not iterating through our array of requests right here, we don't have to worry about any issues around runtime or anything like that. Okay, so with that in mind, let's now flip on over to our code editor, and we're going to create the approve request function. So back inside of Remix, I'm going to go back down to the very bottom of the contract, and I'm going to add on our new function called approve request. I'm going to label as public, and I'm going to make sure that I provide a unsigned integer that we're going to use to specify which request we are attempting to vote yes on. So I'm going to say that we're going to get a uint that we're going to call ID. And actually, you know what? Let's just be really clear and call it index. This is the index of the request that we are trying to approve. Now inside of here, we need to write 2 quick checks, you'll recall. The first check we have to add in is to make sure that this given person who is trying to do this approval right now has not, or excuse me, the person has already donated to our contract. So that's check number 1 that we were previously doing with this big for loop. And then check number 2, we have to make sure that this person has not already approved this given request. So back inside of Remix, we can first start off by making sure that this person is a donator by saying require approvers and then look up message.sender. So we are requiring that inside this approvers mapping, if we pass in message.sender, we should get back a Boolean of true. If that is not the case, if we get back false because we passed in an address that we've never seen before, then this function will exit instantly. Next, we'll add in another require statement to make sure that this person has not voted on this particular request before. To access the requests that we actually care about here, we can look at the requests array at the given index. This request struct right here has a property called approvals. Remember, up here inside of our request struct, we have the approvals mapping that lists or records whether or not a given address has voted on this thing yet. So we will access the approvals property, and inside that thing, we're going to look up and check to see if the address of this sender has been added to the mapping. So we'll look up message.sender. Now, if this person has voted on this particular request already, then this statement right here will probably want to have return true. But remember, require statements will allow truthy values, and they reject or exit when they're given a falsy value. So we're going to add on a not in front of this. So this will say if this person has already voted on this contract and their address exists inside this mapping, that will return true, and we want to flip that to a false. So if it's falsy, we're going to immediately kick the user out of this function call. Then after this, we can place the actual logic to attempt to add this person's address to the approvals hash, or excuse me, the approvals mapping, and we'll also increment our approval count as well. So we can say requests at index, again, that's the request that we actually care about, dot approval count plus plus. So we're using the incrementer operator right here to make sure that, yep, we do in fact increment the number of approvals that we have. And then chances are that right before that, we probably want to make sure that this person is marked as having voted on this particular request. So right before it, we will also access that same thing. We'll get the approvals mapping. We'll say at message.sender, we want to assign the value true. So now if this particular sender ever calls approve request again with the same index, they would then fail this second required check right here. Now, the last thing I want to mention here is that we are accessing the request mapping 3 times in a row right here and doing a lookup operation. Rather than doing that 3 times in a row, we could probably assign it to a local variable instead. So let's take out request.index and assign it to a local variable that we'll create right here at the top of the function. Notice one thing I haven't said very explicitly, require statements can take place at any place within inside of a function. We don't have to put them as the very first line. So we can do a little assignment up here if we want to. So I'm going to say request, and we're going to mark this thing as a storage variable, very important because we want to manipulate the copy of this struct that exists inside of storage. We don't want to make a copy of it over to memory, and we'll call it request. And that's going to be coming from requests at index, like so. Now, if we hover over this thing, you'll see it says unused local variable. That's totally fine. We just have to make sure that we actually make use of request somewhere inside the function. So now we can go back to where we were doing the lookup inside the mapping and replace that with request. We can replace it here, and we can replace it here. Okay, so that's looking pretty good. Let's pause right now. It took us a long time to get to this point. So let's pause here and continue in the next video and test our code and make sure it's working the way we expect.